to the heart of this course, section 2, which is the considerations that you will need in order to build a state-of-the-art mining facility. Of course, the first step in the process of constructing a new Bitcoin mining farm is to determine the criteria for what sort of facility you need. Before anything, you need to know what's your objective before you start putting stuff down on a sheet of paper. The first step is identifying the new mining farm needs. To both start the procurement process and to have a fruitful discussion with prospective suppliers, contractors, consultants, and builders, there are a few main pieces of information that are needed. Don't get worried about this list as we go forward, because we will discuss each requirement that I list in more detail throughout this course. So, what do we need to consider? We can break this down in the following categories, which is space, power consumption, network requirements, redundancy or availability, and location. Space is usually referred to the square feet that you need, but how much square feet that you need is another question. One way you can start is to count the number of cabinets and the number of rack units used in each cabinet. We're going to explore this in more detail. But you need to prepare for items like cabinet width and depth, I/O width, cable, and ventilation space, as well as non-equipment rooms, such as for storage of parts, etc. The next is power consumption. The power consumption not only includes your mining rigs, but also any facility consumption, such as lighting, electronic locks, routers, etc. You will need this to source the service size that you need, which would need to be communicated to the local utility company. I would also recommend to look at the projected power consumption as well, in the case that you want to put more rigs or higher power rigs. You should put a buffer and not to size it as stringent as possible. The thing is that if you size it as the stringent as possible, you might have cases where you have overload, or if you actually want to have some sort of changing of rigs that might require more power, you might overload your service, and you don't want that. So you should actually put a buffer to whatever that you estimate for your projected power consumption. Next is the network requirements. While the data requirements are actually not that huge for crypto mining facility, you still need all of the rigs to be connected to a network. So you would need to consider what kind of service that you need with thousands of rigs connected to the central network with which you can remote in off-site. Then you will need to look at the redundancy and availability. In this case, the loss of availability means loss of income. So of course you want your machines to be up at all times. But at what cost? Well, this needs a further cost and benefit analysis to find out. Lastly, location. For location, you need to look at a place where the cost is low. However, there are various criteria that you need to look at, and there are no set formula in defining the best location. The land price might be low in very remote and rural areas, but getting power there might be costly if there are no infrastructure there to support your mining operation. You may also need to find areas that are stable, such as low probability of earthquake and flooding, etc. We will look at each one of these in more detail. In this video, I would like to talk about some pointers of where the mining farm should be located. So now let us go through the list of requirements as can be seen in front of you right now. Let's start off with floodplains. First of all, you should avoid building your mining farm on a location that has flood risk. Flooding will cause your entire investment to be permanently damaged due to water. Yes, floodplain locations are usually cheaper, and there are mitigation technology to reroute water. But why take the risk? You can get a flood risk information usually from any local government, so I recommend you to review it against any location that you are interested in. The next thing is relevant distance. When I'm talking about relevant distance, I'm referring to distance from you and your operation team from the mining facility. I know that you most probably are going to remote into your operation for most of the time, but I would advise you to locate it within an hour drive from the site to where you and your operation team are situated in. The reason for this is so that in the case of situation that you will be required on site due to certain emergencies, you can still arrive promptly. Lastly, it is neighbors, and this goes towards if you are sharing the same building or different buildings but close by. You would want to know how risky the location is to your mining operation. For example, if other businesses deals with a lot of explosive materials or other chemical products, you should actually avoid building the mining farm near these businesses. Now, the last three requirements are the responder proximity, major roadway proximity, and the nuclear risk. Now for the responder proximity, this is just a good to have, but not a must. The proximity of a fire station allows firefighters to respond to fires on or around the vicinity to the mining farm, and proximity to the police station may deter the possibility of theft. Again, the proximity to responders it's just nice to have, and it allows you to have a peace of mind, as you will know that the firefighters and the police can respond promptly to any emergencies that occur surrounding your location. But again, it's not an absolute requirement. Now, the next thing is major roadway proximity. I personally would avoid major roadways as it has risk for potential vehicular accidents and such. But again, it is not a huge major concern, as you shouldn't be anticipating that people would go from major roadways directly to your site and crash into it. However, though, given a choice, I would not want to site a place that it's next to a major roadway where there are a lot of cars. Now, lastly is the nuclear risk. And the main reason is that there is a 50-mile evacuation zone for nuclear power plants. So a 50-mile area around the facility would be subject to evacuation if there is any kind of a radiation spill or any more significant incident. So in this case, I would recommend to avoid this 50-mile radius from any nuclear power plants. But again, these last three in general are actually not major requirements, so it's just a nice to have. For example, the nuclear risk, right? Even though that it has an evacuation zone in which if you are situated 50 miles within a nuclear power plant, you will need to be evacuated. However, though, mostly you would be remote into your mining facility, so it won't be applied to you. It won't cause inconvenience to you. But if you, let's say, have a security team, then you might have the security team be evacuated when such things occur. So again, it's not a make or break deal if you got a nuclear power plant close by, but it's a nice to have, and it's preferably to avoid that 50 miles. Before you are building your Bitcoin mining farm, you will need to know the amount and type of space that you need, as failure to precisely communicate what you want in terms of space will definitely hurt your future operation. So in this video, I'm going to go over the consideration points for you in terms of facility space for your mining farm. Let us start with white space. White space is defined as the area with which your mining equipment is placed. Now, the white space is three-dimensioned, which means that if you don't have enough floor space, you can make it up by building upwards. which means higher cabinets and racks. Now, with floor space, please do keep in mind that we need to also provide accessibility space so that we can access our rigs comfortably for maintenance or replacement work. Also, we need to include space for cable routing and proper airflow. With flooring, especially if you have a greenfield facility design, you can choose between raised floors and hard floors. Let us look at these two options. Let us start with the raised floors. The main use for these is for airflow circulations, such as the targeted and enclosed architecture that I will be going over in the later cooling section. Now, aside from cooling, you may consider raised floors for the purpose of routing cables or establishing a ground grid for your equipment. Having raised floor has a distinct advantages, being that it allows easier way to direct airflow as well as the ability to reroute cables more easily. However, on the other hand, it comes with a range of disadvantages as well. For example, point loading is an issue to heavy equipment focused on a single point on the floor may actually wreck the floor itself. Furthermore, if you need to reroute cables, it is actually harder to reroute in under the raised floors, and to top that off, you cannot congest the raised floor space too much or it will impede the airflow. And speaking of the cable rerouting, you will need to remove the tiles while rerouting, which means that if you remove too many at the same time, you might create too much stress for the infrastructure. And if you forgot to put some tiles back in, you might injure someone when they accidentally stepped into the hole while maintaining the rigs. Of course, the other option is the hard floor. This simply means that all of your equipment is placed on just concrete slabs. With this option, there are two advantages to it, such as that it is cheaper and it's less susceptible to damage. As for the disadvantages, it is mainly that all the cooling and cabling will need to be fed overhead through ductwork. And if you need to reconfigure ductwork, for instance, in rerouting cables, it is actually much harder to modify ductwork than pulling just a few tiles underneath. Let us now talk about the fire suppression system. In a lot of facility designs, the fire suppression system is often just an item in the checklist for many facility builds, including mining farms, and there are not many considerations being put towards it. The main reason being is that while power and cooling are vital to the farm's everyday activity, fire suppression only comes into play when something has gone wrong. Now, to be quite honest, you do have little to no control over the fire suppression system, especially if you are in a co-lease space or brownfield construction. That said, you should still know what is in place and how the system protects your mining farm. So now let us go over the major components of the suppression system. And there are 5 components in general, which is the fire alarm, extinguisher, EPO switch, delay switch, and the agent. The detection system is intended to determine whether a real fire has begun or just a false trip. And to prevent false alarm, the detection system should detect both smoke and heat. As for the fire alarm itself is to signal appropriately that anyone needs to evacuate. So this should include both sound as well as visual, such as in the form of blinking lights. This should usually be described within the required building codes. So the look and feel of the fire alarm is basically defined by whatever that's set up regionally in your local building code. Now, as for the fire extinguishers, it needs to be installed at key positions within the mining farm facility. The need for portable extinguishers may seem unnecessary, as the facility usually have an automated suppression system of its own. But in reality, this is to ensure that the workers have a way to extinguish fire between themselves and the exit from the facility, which should be included in the design. Now, also another thing is with the portable extinguisher is that if you see a particular equipment is just starting a small fire but has not been spread, the particular worker can actually use the portable extinguisher to actually quickly extinguish the equipment. And usually these extinguishers, even if you use it, it won't harm your equipment. So in this case, not only the people, it would also protect the equipment as well. So the next one is the emergency power off switch, or the EPO switch. In the event of a fire, the EPO, or the emergency power off switch, will automatically cut off electricity for safety. In addition, in the case of a catastrophic event, such as the electrocution of a team member, there is also usually an EPO switch that needs to be installed in critical location, such as a main entrance door for manual power cutoff. Again, a lot of things here is to actually prevent harm to you or your team that it's operating within the mining farm facility. Then there is the delay switch, which is a switch used to delay or cancel the suppressant dump in the case of a false alarm, or whether the personnel needs more time to get out of the facility before the fire suppression system dumps the suppression agent. And lastly, of course, there is the suppression agent, and this is the material used to extinguish a fire. Ideally, the facilities will not be ruined by this suppression agent, and it won't take too long to clean up. However, though, this may not always be the case. The suppression agent may range from various kinds of gaseous suppression system to just a water-based agent. Having just said about the suppression agent, let us look at the types of suppression system. There are generally three common types of suppression system, and they are the water-based, the pre-action, and the gaseous-based system. The water-based basically uses a sprinkler system, and the second one, the pre-action, is still using water, except that the pipe is kept dry until a fire is actually being detected. The third system, and also the most expensive one, is the gaseous-based system. The system utilizes agents that removes oxygen and heat from the environment to extinguish fires. Although your rigs might not be damaged by water like the other two systems, the agents in the gaseous-based system is not human-friendly, so you need to be sure that the workers or whoever that is inside, including yourself, can evacuate before the agents get released. So hence why you get the delay switch that I have introduced to you just moments prior. Again, your choice is very dependent on the facility space that you are using. So there is very little control on what you have as a suppression system. Another space, as I mentioned earlier, that is very important for you to consider is the vertical space. And the vertical space needed is very dependent on a few things. The most important part is the height of the cabinets or racks that you will be deploying. Then the layer of cables that you're going to have above the cabinets or racks, and then the ductwork above. Of course, the most important equipment in this case is the cabinet. The level of scale of your farming operation is often not determined by the cabinet space that you can have within your farming facility, as this limits how many rigs that you can have installed. Thus, you need to pick your cabinets or racks carefully when you're constructing your farming facility. Cabinets and racks are measured in what is called the rack unit. A rack unit is usually 1.75 inches in height. You need to look at the specification of the rigs that you want to buy to see how many rack units it takes up. Some of them will say it in their specs, mostly when you are buying GPU rigs. Some ASIC rigs only supply dimensions, and sometimes they are not compatible to be installed in traditional cabinets. If your ASIC rigs are not compatible with traditional cabinets, then you need to procure or build a custom mounting structure to house these rigs vertically. I would say a lot of the ASIC rigs do have compatible mounting brackets to be installed on traditional cabinets or racks. Lastly, I wanted to go over other miscellaneous spacing requirements. The standard width of the cabinets are 24-inch, but sometimes you might want to prefer wider cabinet solution just so that you can have better cable management. So in that case, I would actually recommend to use 30-inch width cabinets just so that you can manage your cables more effectively. And speaking of cable management, you need spaces between the top and bottom of your rigs for accessibility and, of course, again, cable management. So be sure not to jam pack everything, all of your rigs together with no spacing between it when you are calculating how many rigs you can have within a cabinet or a rack. Now, I would also recommend to leave at least 3 feet between the rows of cabinets or racks to allow accessibility for maintenance as well as to optimize airflow. Outside from that, the cable is another important factor when looking at the space that you need. We will look at cabling in another video of this course. Lastly, you may have backup generators, switches, as well as other items such as electrical panels, etc. And most of these will require specific clearances as well as other miscellaneous requirements. These requirements will differ depending from where you are located, so please check your local electric code for further details. Perhaps the most significant component of the Bitcoin mining farm design process is the emphasis on supplying the mining equipment with the adequate power. You may or may not have any experience and knowledge of power and electrical system, and in many ways in which they supply power to your mining farm. So that is what this video is for. We will analyze electrical system and how electricity is distributed all the way from the generation plant to the receptacle into which you plug your equipment before we discuss the specifications you need to specify for your Bitcoin mining farm project. So how electricity is supplied to the mining facility is essentially based on how you determine your requirements. You will never need to know the in-depth architectural considerations of the electrical utility portion unless you are studying to become a utility power engineer like myself. However, you will need to know the portion of which it supplies power to your facility, as knowing what options is the best will save you in a lot of time and cost. In simpler sense, the multiple distribution configurations can be split into 4 general categories that is shown in front of you, which are the single feed single substation, the dual feed single substation, the dual substation, and the real dual feed. Let us go over each one of these in more detail. Most of the mining facilities should fall into this category. This is by far the simplest and the least costly approach. One funny thing is, I even see many more crucial operations, such as data centers, utilize this configuration, but they also had a false sense of security, thinking that they were fed from multiple feeds. Let's look at the diagram in front of you. In this configuration, you will find in this setup that there is only one single feed from a single substation. The facility is then connected to several local transformers fed by this same source, giving more than a single feed appearance at the facility. This gives a false sense of security, as if there is anything happen to the main feed or substation, the facility will be without power anyways. However, I would recommend a single feed, single substation approach without the need to have multiple transformers feeding into your mining facility. The reason is simple, because this is the cheapest option. But then you might ask, Mike, what happens if there is an outage? Wouldn't this cause my farm to be without power and may even damage my rigs? Well, I will get back to this later in this course. Although I have given my recommendation on the configuration to be used, let's still go over the other ones that you may want to consider. Keep in mind that these are much more costlier solutions but offer more stable supply of power from the utility. So let us go over the last three configurations. So the second one is the dual feed single substation. This differs from the previous configuration by adding one additional feed from a single substation, where the feeder is chosen using a throw-over switch. This in turn eliminates the risk of a single line breakdown, triggering a sustained outage by providing two distinct feeds. With the use of only one substation as the power source, this configuration nevertheless still holds a high probability of extended power outages. Not only that, the feed downstream of the switch into your facility is still maybe susceptible for a single point of failure. The third configuration is the dual substation. With this configuration, you still have a throw-over switch, but now the two feeds are coming from two different substations. Again, the feed downstream of the switch to your facility is still maybe susceptible for a single point of failure. And the last configuration is called the real dual feed. With this one, there's no throw-over switch, and both feeders each are going to be from a different substation. It's going to be directly fed to the facility, and inside each should be redundantly supplying power to your assets or rigs. And this last one is going to be very, very, very reliable, but it's also going to be very, very, very costly as well. With your mining farm, the most important part of the infrastructure is the power, as it powers up your rigs. Power outages, if not handled correctly, will damage your rigs. Also, your mining farm would most probably at a remote location where it would take considerable effort to get all of the rigs back into operation. As such, it will be in your best interest to have a state-of-the-art electrical design and minimize the outages to a minimum. Before starting on looking at the design itself, let us go over some terminologies. This is important, especially if you have no knowledge of electricity prior. Of course, without boring you to death, my explanation is simple. You need to keep tabs of the power needed in watts or kilowatts of all of the equipment that you need within the farming facility. And I'm not only referring to your mining rigs in this case, I'm referring to all of your equipment that uses electricity, such as your lighting. One of the key design priorities would be to improve the facility's power efficiency, which means that any design inefficiencies need to be fixed and planned whenever possible. Some examples of improving electrical efficiency for your farm includes using LED lighting and a UPS with very efficient and low loss, and so on. It is also necessary to reduce any power loss through the cables both outside and inside the farming facility. This is of particular importance in mining farms, as the loss of power will result in heat generation. Depending on the scale of the mining farm, your local utility may offer you with two solutions on their utility feed. What I'm talking about is not the configuration, but the voltage of your surface. If your mining farm is still considered as a small scale, utility companies may just install a pan mount transformer close to your facility and supply you power in the 120 to 600 volt range, or what we call the secondary voltage range. Now, after your power requirements reached a certain level, and this kind of varies between utility companies, so I couldn't tell you at what range will they be looking at this configuration, the utility company may simply supply you with a service feed that is of medium voltage. What I mean by medium voltage is from 4 kilovolts to 35 kilovolt range. With medium voltage service feeds, you will need to have a step-down transformer within your facility to step it down to secondary voltage level ranges to meet your equipment needs. Now, in terms of services, there are also differences between a single-phase and a three-phase service. Single-phase service is mostly residential services where there are 3 wires with 2 hot wires and a neutral. For example, in a 120-volt single-phase system, 120 volts will be supplied by 1 hot wire and a neutral, while 240 volt can be supplied to more power-intensive equipment such as washer and dryers with the 2 hot wires. However, with your mining operation, you will most likely be accustomed to the 3-phase 4-wire system where it is usually supplied from a Y secondary, and it is essentially 3 wires of 3 different phases and a neutral. Less common will be having the 3-phase service being supplied by a delta secondary transformer where now you will have 3 wires instead of 4 going into your facility. The reason for the 3 wires only because delta connections would not have a neutral. Current rating is essentially the limit as to how much steady-state current an equipment can safely sustain. The electrical equipment's rated current means that the equipment can maintain the current continuously without reaching its temperature limit. For example, the temperature rise. This is a very important parameter for electrical components. If any type of current limiting mechanism within the equipment itself cannot stop the overcurrent, the device will surely heat up and catch fire. The rated current is also the highest amount of current a device can draw. However, this rated current does not refer to the real current that a device will draw. In most instances, much less than the rated current would be drawn by your equipment, even for your mining rigs. The reason is mostly because exceeding the electrical equipment temperature cap will lead to failure of the equipment or even fire. In a Bitcoin mining farm, all electrical devices must be shielded from overcurrent situations, such as overloads and short circuits. For this purpose, a component within, like a circuit breaker, will be integrated to guarantee that the rated current are not surpassed. These components are responsible for opening a circuit in conditions that are overcurrent. For all these types of components, it must be able to tolerate brief bursts of overcurrent pressures before activation of the overcurrent protection system, as we don't want any false trips. In a mining farm facility, there are different types of equipment deployed to supply power to the rigs in both a redundant and complex manner. Here's the list of common types that you need to know in front of you, which is the switchgear, the panel boards, the switchboards, the power distribution units, and the uninterruptible power supply. So let's start off with the switchgear. The switchgear contains a mix of electrical disconnection switches, fuses, or circuit breakers used to operate secure and separate electrical equipment. In order to allow work to be performed and to clear faults downstream, switchgear is used for de-energization of equipment. This type of machinery is related directly to the efficiency of the supply of electricity. Interrupting short circuits or overcurrent to maintain operation of other circuits is one of the most essential features of the switchgear. The switchgear is often used to allow a load to be fed by more than one power source. If you have a medium voltage directly coming into your mining facility, you most likely would need to have a medium voltage switchgear along with a step-down transformer. Medium voltage switchgear is normally installed in the facility's electrical rooms. The utility feed demarcation point in this case would then be right at the medium voltage switchgear. That is the location at which the medium voltage feed is terminated within the facility. If you have a medium voltage generator, it would also be connected to this. It is also the duty of the medium voltage switchgear to disconnect faults and to monitor the medium voltage power delivery. For example, when isolating a section for purposes such as routine maintenance. Medium voltage switchgear can be relatively complicated to spec, as it has a plethora of components such as meters, circuit breakers, contactors, fuses, surge arresters, PTs, CTs, and various relays, etc. You don't need to know all of the intricacies of these components, as usually the manufacturers, and I'm talking about the big ones, will already pick the best ones, and they can tell you whether or not it meets the standards of your local region. What you need, however, is to look at the following properties to see if it suits your needs. And these are shown in front of you right now, and we got 5, which is the first of all, it's the rated voltage, which is the peak value of the voltage that the equipment will tolerate on an ongoing basis, and it is normally chosen to be marginally higher than the operating voltage. Then there is the current rating, which is the peak current value that the equipment will tolerate on an ongoing basis. Third, there will be the impulse withstand voltage, which is an indicator of the device's insulation to tolerate overvoltage resulting from external faults, such as a lightning. Fourth, there is the power frequency withstand voltage, which is a measurement of the equipment's insulation strength to prevent overvoltage resulting from internal faults or switching. Lastly, there are the physical dimensions, and we need this to see what is the footprint of it and how can it be installed within our mining facility. Within the facility, you may also need to install low voltage switchgear as per your design if you require centralized protection and control of your low voltage equipment, or what I mean by that is your mining rigs. So the next components are the panel boards and the switchboards. Now, panel boards is a distribution board that helps splits the electrical power supply into subsidiary circuits, supplying each circuit in a common enclosure with a safe fuse or a circuit breaker. Switchboards, on the other hand, is a device that directs electricity to many smaller regions of use from one or more sources of supply. It is an assembly of one or more panels, and each containing switches that allow for the redirection of electricity. Now, a switchboard function is to allow for further diffusion of the current supplied to the switchboard into smaller currents and to provide switching, current safety, and possibly metering for these different currents. Switchboards will typically distribute power to transformers, panel boards, control equipment, and to individual system loads. Now, for a power distribution unit, or short form as PDU, is a multi-output system designed to distribute electrical power, especially to computer cabinets and networking devices. So in this case, it is used to support for our rig cabinets. These are typically used in data centers, but we are going to use it for large-scale mining farms as well. And just think of this as just very large power strips that we use to supply power to our racks and cabinets. Lastly, I want to talk about a very important component in the electrical system for our mining farm, which is the uninterruptible power supply, or short form as the UPS. This is an electrical device that provides emergency power to a load, in this case our mining rigs, when the input power source or main power fails. The UPS systems are designed to only function for a finite period of time to provide emergency power, typically in minutes. Usually, they're defined to maintain the operation of the equipment just before any other emergency power source can be kicked in so that you can restore to normal usage. So in this case, another power source that can be kicked in can be in the form of, let's say, a backup generator. One of the most important thing when looking at the UPS is its hold time, and it is characterized as the amount of time from the lack of main power until the batteries are no longer able to provide the power needed to keep the load power within the specifications. Now, if you're not considering any backup power solution, for example, you're not going to utilize or install a backup generator, then a UPS should be spec'd with a holding time enough for the mining rigs to gracefully shut down. And when the UPS kicks in, you can configure it to have a loud beep, and some can even have sending out a remote signals which prompts you as the user or for your team to shut down all of your mining rigs before the actual power failure kicks in, so that you could prevent any permanent damage that can be done to your mining rigs due to the power outage. There are only a handful of requirements of the facility design that will affect your long-term cost, availability of system, and overall success, more so than how you define your power requirements. For example, you will run out of power before you have filled your space with mining rigs if you underspecify the amount of power you need. On the other hand, if you overspecify your energy requirements, you will pay more for your space than you need. You will need to consider how much power the overall facility can consume, whether you are constructing your own mining facility or just leasing a co-location space. In such a case, you can create a spreadsheet and plug in a nameplate maximum power from the spreadsheet for each component that will be in your mining facility and just sum them up. If you don't trust in the specs of the nameplate to be realistic in your situation, and let's be honest, in most cases it won't, you can take real measurements with power meters of the component and multiply by the quantity that you will deploy. Now, it is not too difficult to get current power consumption, but projecting what you need for the future will be the harder part. With this, you will need to provide an estimate that over a reasonable time period, how much extra mining rigs can you imagine being deployed, and how much power each of these mining rigs can consume. The tricky thing is that mining rigs actually would have different power consumptions, so it's actually a bit harder to gauge it. But you can actually just ballpark it based on what you have in your current model of mining rigs. Now lastly, I wanted to talk about power billing methods. For billing, there are many different ways that your facility can be charged. The way you're paying for electricity has a profound effect on your operating cost. The cost of electricity, in my opinion, greatly outweighs the other factors, including the cost of space itself. The two common billing methods are what we call the circuit-based billing method and the meter usage billing method. Let us start with the circuit-based. You are charged a fixed price for power circuit in a circuit-based billing environment, no matter how much electricity you actually use from that circuit. Basically, at all times, they charge you for 100% usage of the circuit, whether you consume the maximum amount of power permitted by electrical code or not. Even with mining rigs typically running at 100% most, if not all the time, I would still be careful in signing for this type of contract. So I would recommend you to instead look at the second type of the billing method, which is the more common type, the meter usage billing. Now there are generally two components of this type of billing, which is the actual cost and the upcharge. While the actual cost is self-explanatory, which is the cost of power that you consume in the facility, the second component, the upcharge, would appear if you are co-leasing a space, in which the monthly charges for the auxiliary shared power consumption, such as cooling and or security system, would go into this upcharge. The upcharge might be distributed proportionally by the percentage of space your facility takes up in relation to the entire complex. Now, there's also another thing with the upcharge, and is that if you go above a certain threshold of your electricity usage, you might actually need to pay a premium as well. And that also goes into your upcharge portion of that electrical billing.